All right. Can you all hear me okay? Quite loud and echoey. All right. I had to do this. Subxt is awesome. This is why. Right. So this is a talk about Subxt. Could I get a show of hands for has anyone used Subxt in the audience? Cool. Anyone not used it? Okay, like sort of half and half. Cool. Right. So basically, in this lecture, I'm going to be introducing Subxt, talking through some of the stuff it can do, showing you what it looks like. I'm going to ramble on about how awesome and flexible it is and all the cool things you can do with it. And then finally, I'm going to look at some of the crates it's built on. So if you are interested in doing similar things but not Subxt, then maybe some of these crates will be interesting to you. So let's get going. So first off, what is Subxt? For those that don't know already, Subxt is a Rust library for interacting with substrate-based nodes. And I guess the way I think about it is it's like Cappy or Polkadot.js, but written in Rust instead. So it's the same kind of tooling. If you want to talk to a node, Subxt is one way to do it. What can you use Subxt for? I guess the main thing is submitting extrinsics. It's kind of the main thing you want to do with a blockchain. But also, if you want to subscribe to blocks, access the extrinsics in a block, find out what events were related to that extrinsic. If you want to access storage entries, if you want to access constants, you can do all of that with Subxt as well. So Subxt is really a tool for interacting with a blockchain, for setting state on a chain and getting state back from it. And just to sort of give you some reason for why would you use Subxt in the first place? Why not just do this manually? And to give you a quick example of that, doing it manually is hard. It's not easy. So for example, if you want to submit a transaction, this is what you've got to do. First off, you have to understand the JSON RPC protocol, and you've got to know what method to call to submit a transaction in the first place. When you understand that, you need to understand the protocol, how to assemble the bytes that create a transaction, how to put those bytes together in the first place. That's another thing you have to figure out. You have to figure out what types and values are needed. So every transaction has a different set of parameters that you can pass to it. They all have different types. Those types can be quite complicated. So you need to understand about those types and how to encode things into those types. You need to figure out how to sign the transaction and what the format of that is, where to append the signature. You need to understand what signed extensions are and the fact that every chain has different signed extensions. This is all getting a bit complicated. And you have to figure out how to scale, encode, and decode everything. And finally, when you've done all of that, you've assembled a transaction, you've submitted it to the blockchain, you need to understand when is it finalized, when is it in a finalized block, and when is it successful. And so you then need to understand the back and forth required to do that as well. And finally, I guess the other thing is you need to be able to access the events related to that extrinsic. You need to know how to decode those events, and you need to know what to look for to understand whether that extrinsic was actually successful or whether it failed. So Subxt just does all of that for you. You don't need to think about it anymore. It's just a quick slide. I wanted to just say how Subxt works really roughly. What Subxt does, it basically, when you connect to a node, it will ask for the metadata from that node, and it will use that metadata, it will use all of the type information in that metadata to generate the interface that you use to talk to a node and to understand how to encode and decode all of the data that's sent back and forth from a node. So just a shout out to scale-encode, because without this latest v14 metadata with all its type information in it, and without scale-encode, the crate that Subxt depends on quite heavily, this wouldn't be possible, or it would be really difficult. And yeah, just check out, if you're interested in knowing more about metadata, check out frame metadata. That's where metadata is defined. And if you want to know more about types, then check out scale-encode. Right, so I just want to have a few slides. I'm going to show a bit of code, but I'm going to kind of race over it fairly quickly. You don't have to understand the code too much. I just want to give you a feel for what it looks like to use Subxt in practice. So I'm going to skim over these slides a bit, and you do not need to understand or follow along the code. So I'm going to start with just the easier example is if you want to access a constant on the blockchain. And these steps are kind of common to all of the things, which is why I want to do this. So step one is you generate some types. You generate an interface to allow you to talk to a certain blockchain. Then you build a client, a Subxt client. And in this case, we're building a client to talk to Polkadot. So we pass it Polkadot config. And then you build a query. And in this case, the query says, I want to access the existential deposit constant from the balances palette. And then finally, you take that query, you pass it to the client, and you get back your constant. And just to show you how similar all of the other things are, if you want to access storage entries, it's the same kind of thing again. You build a client, you build a storage query that says this is the kind of value I want to access, and then you pass that query to the client, and you get back the value. Submitting extrinsics, it's sort of similar, a little bit more complicated because there's a bit more to it, but again, you create a client, you build a query, or in this case, a payload for like, this is the extrinsic I want to submit. So in this case, I'm building a balances transfer extrinsic, and I'm saying I want to transfer Bob 10,000 dots. And just FYI, testing this code was really expensive. Then I take that balance transfer, I submit it to the API, and I wait for it to be finished and successful. So this like wait for finalized success thing at the bottom does quite a lot of stuff for you behind the scenes. But when it's done, you know that everything was submitted, finalized in a block, and it's successful, it all worked. Ooh. And the final thing you can do with Subxt is you can subscribe to blocks. So if you want to know what's happening in the network, you can subscribe to blocks. You'll get given back each block as it's produced. You can subscribe to finalized blocks, or just the current best blocks, or all of the blocks that are seen by a node. And then you can do stuff with the blocks that come in. So you can get the block number, you can get the block hash, you can access the body of the block, and from the body you can pull out all of the transactions that are in the block. And from the transactions, you can access all of the events that were associated with those transactions. So it's quite a nice, I think, quite an easy-to-use API for accessing all of the details you might be interested in to do with blocks. There are some things that are missing, but they are soon to be added, and we'll get to that later. So just to kind of spot the similarities, like everything kind of works the same way. In every case, you generate some types that you want to use to interact with a blockchain. You construct an API client. You build the query or the payload or the thing you're interested in accessing, whether it be a constant, a storage request, or a transaction payload. And then you submit that to the API client, and you get back the result. So hopefully it's fairly easy to use. And I just want to focus on this like separation from constructing a query and passing it to the API to use it, because this isn't actually a thing that like libraries like Polkadot.js do. It's all wrapped into one step where you both construct and send it in one go. But actually, if you separate those two steps out, you get a lot of flexibility from it. And I just want to take a little bit of time to talk about some of the cool things you can do with Subxt because of that. So first off, I'm going to talk about the client itself. And the client is the thing that you create at the top and then submit things to. So first off, all of the examples I've showed you so far have been submitting stuff to Polkadot. So they've got this Polkadot config thing. But actually, if you want to talk to a parachain or some of the default substrate node or whatever else, you can tweak that config. So the config basically has, it's a trait that defines all of the things that are different between different chains. So like the block number type, for instance, or the type of the signature, or the type of the signed extras that you can include in a transaction. So basically, if you have a parachain and you want to use Subxt, you can implement your own version of this config that's specific to your chain, and then Subxt will understand how to interact with that and make the most of it. And just to say, we get the default substrate config and Polkadot config out of the box. Another thing the client gives you is offline mode. So this is something I don't think you get in Polkadot.js or Cappy or any of the other libraries. Because of this separation between building a client and building and submitting the data, we can actually build an offline client instead of an online client. So basically, any functionality you want to do with a node that doesn't require you to be connected to the node, you can still do that functionality offline. And just to give one quick motivating example of that, so if you're using a signer, for instance, what you might want to do is construct a transaction entirely offline, sign it offline on some offline device that has no access to the internet, take the bytes for that, and then maybe hand the bytes to a different device and submit them. And with Subxt, you can do that kind of thing, because Subxt, you can construct and sign your transaction entirely offline. You don't need to connect to a node, know anything about the node whatsoever in that way, and then you can send that transaction off to something else that can submit it for you. And offline and online mode are all entirely trait-driven as well. So as we add more functionality, any functions that don't require you to be connected to the node will just automatically work for the offline client. And just one of the other things you can do with a client that I think is kind of cool is actually customizing the RPC interface itself. So how this works normally is a client will use JSON RPC under the hood to do all of the JSON RPC things that it needs to do to talk to a node, which includes understanding how to create the payloads and decode stuff on the other side. If you don't want to use JSON RPC, then you don't have to. You can use your own RPC library. If you don't want to do any network communication at all, maybe you want to embed Subxt in a light client or do something like that, you can do that too. You can customize this JSON RPC layer to talk to something in process instead of talking over the network, for instance. And so this layer gives you a lot of flexibility, and it's something that we plan on making use of to, at some point, connect Subxt to Small and have a light client implementation so that we don't need to be tied to any single RPC node. So that's the client. I want to talk quickly about the payload next, and the payload is the stuff that you submit to a client. So one thing you can do with a payload, I guess something that I've kind of glossed over so far, is that we are always generating our kind of static interface and then making use of that static interface when we talk to a node. And one of the questions is, how do we know whether that static interface is actually in line with the node you're talking to? Like maybe the node has been updated since you generated that interface. Maybe things have changed. And maybe that interface isn't valid anymore. And so something we do is validation on all of our static payloads. So when you construct any kind of transaction, any kind of storage request, constant request as well, I think, they basically all are validated by default under the hood when you try submitting them. And what that means is if the node has changed in the meantime, if the signature of the specific transaction you're trying to send has changed, if any of the types have changed, then before we try submitting that to a node and potentially having some weird breakage or something going wrong that you don't want to go wrong, you'll get an error back saying, hey, hold on, the signatures have changed, so you might want to do something about that. And what that probably means is you might want to regenerate your static interface and bring your client code up to date to match the current node code. However, if you don't want stuff to be validated, you can opt out quite easily and just say, I don't care, send it off, let's just see what happens. One of the other things about the payload is we've been talking about statically generated code all this time. But one of the questions is, what if you want to write an interface like Polkadot.js, where you have users submitting dynamic data and dynamically shaped transactions for you to then submit to a node? How would you do that? And you can't really do that with static data because you don't know what the shape of the data is that the user is going to be providing to you. And so Subxt supports dynamic data as well. And basically what this would look like to use really quickly is you can throw away all of the static code gen, and instead of doing any kind of code gen at all, you use this dynamic module, and you construct a dynamic payload instead. And this is completely arbitrary now. You have to name the palette with a string, you name the call that you want to make, and you pass in a vector of arguments. And Subxt has no idea whether, when you're constructing this, it has no idea whether it's valid or anything, because you could have any number of arguments you want. The arguments can have any kind of dynamic types. But when you try submitting that, well, yeah, basically Subxt has no idea because it's fully dynamic. And And just to kind of like, why is that interesting? Where can I use it? You can use it anywhere you would use the statically generated interface. You can actually use the dynamic types as well. So when you're constructing transactions, constants, storage entries, all of that can be entirely dynamic. When would I want to use that? And like I said, I think you'd want to use it for any kind of user-generated input. So if you want to write a JS app, for instance, that allows users to construct like arbitrary transactions and submit them to a node, if you're doing some kind of CLI app that allows users to provide custom values or types that you need to try and submit to a node to do something, that's when you might want to use dynamic types instead of static types. And do you have to use either dynamic or static types? And the answer is no. Like with Subxt, everything is trait-driven. So this like type thing where you can either submit a dynamic type or a static type, if you don't like the way that I've written dynamic types, you can create your own thing. You can just do whatever you want, as long as you can implement a single trait, which looks a bit like that. So as long as you can say, I've got some stuff, and I know how to encode that stuff to core data, then you can use that stuff. And you can pass it to Subxt. Subxt will understand how to make use of it and how to submit it as a transaction. And the same is not just for transactions, but the same is true for storage and constants as well. You can implement the trait yourself to use your own custom types and submit your own custom types to Subxt. So just to recap some of the stuff I've talked about quite a lot. Let's just recap it real quick. So Subxt is responsible for submitting transactions, doing storage lookups, constant lookups, on all kind of block-centric stuff, subscribing to blocks and pulling data from blocks as they come in. You can customize the client config to work with different chains. Subxt supports online and offline mode. You can customize the RPC client, i.e. how Subxt communicates with a node in the first place. And all of the static types you use are validated by default. So if the node changes and you haven't updated your static interface, then you know about it and you won't get some kind of crazy shock where something happens that shouldn't happen. And finally, you can use static or dynamic types all the way throughout Subxt. Or you can implement your own way of passing types. So that's like Subxt, and that's a brief overview of a couple of things I think are kind of cool about Subxt. And if some of that is interesting to you, but some of it isn't, if you'd like to do certain things with scale-encoded types, but you don't need all of the other stuff that Subxt gives you, then you might want to look at some of the libraries that Subxt is using under the hood. So I'm going to really quickly just shout out to some of the libraries under the hood in case that would be interesting. So I mentioned this earlier. Scale-info is basically the library that generates type information for all of the types that are exported, essentially, through Substrate. So any types that are used in the transaction interfaces have this type info thing implemented on them. And what that means is we get all of the types we need in the metadata, and we can generate all of the core interfaces that we need to generate in Subxt. So scale-info is really awesome. If you need to do stuff to do with describing types and the shapes of them, and understanding then how to encode and decode, start looking at scale-info. In order to do the dynamic things that Subxt does, it relies on this trait called scale value. And scale value basically provides this value type, which is a lot like surd.json's value for anyone that's used surd.json. And the value basically represents anything that can be scale encoded and decoded via this type info trait that scale-info provides. And roughly, it gives you back two things. It gives you one function that takes a value, some type ID, and some registry of types. And it can take that and encode it into some scale-encoded bytes. And then it can go the other way around. If you take some scale-encoded bytes, some type ID saying this is what I want to decode those bytes into, and the registry of all the type information, then it can give you back a decoded value from that. And values are really flexible. They can be serialized and deserialized using surd. They can be serialized into, they can be deserialized from, so they implement like all of the surd traits. And also they can be parsed from strings and converted to strings. So if you want to write like a command line app that takes in some dynamic value that you can scale encode into bytes, then it can do that. And just to give you a really quick example, this is the kind of string that you could type, and that would be encoded into a variant type with a name of ID, and a couple of fields, like a number field that's a number, and a balls field, tuple of balls, and a string. So it's hopefully quite familiar. It looks quite a lot like JSON, apart from the variant support that we have to have, and it's hopefully quite easy to use. But if you want to go a little bit deeper, maybe you don't like the value type. Maybe the value type allocates too much, or maybe it doesn't give you the flexibility you want. Well, scale value itself relies on some other crates to handle the decoding and encoding stuff. So maybe what you're interested in doing is taking some scale-encoded bytes, a type ID, and the registry of types, and outputting your own custom type. Scale-decode can do that for you. So basically, scale-decode provides this visitor-like trait, and if you implement this trait and you say, this is how I want to decode different types, then suddenly you can take some scale-encoded bytes, run it through your visitor, and you get back your own custom type. So it makes it really easy to decode things, and it's used under the hood for scale value. And also, it can be used to do stuff like skip over scale-encoded bytes without allocating. So we use that to skip over events and find events when we're searching for events in Subxt. And just a quick shout out to a library that I'm working on right now and I'm quite excited about. So scale-decode takes some scale-encoded bytes and returns your custom type. But what if you want to go the other way around? You want to take some custom type and get back scale-encoded bytes. And that's what scale-encode is for. So scale-encode basically builds upon Parity scale codec and supercharges it with superpowers. And basically what it does is it enables, you write a static type. The idea is you create a static type, you derive this new encode as type trait on it, and suddenly encoding that type will have all of the flexibility that encoding dynamic types would have. It will understand how to map the values in your type to the values that you're trying to encode into. So for instance, if you pass it a U64 and you need to encode it into a U32, it will understand how to do that mapping for you. If you pass it a struct that has more fields than you need and try and encode it into a type that only needs a couple of those fields, it will understand how to do that. It will say, well, I don't need those fields. I'm going to encode only the fields I need. So it basically gives the static encoding this extra flexibility and power based on the target you're trying to encode to. And that's basically what I'm working on at the moment. If you want to know more about Subxt, then first off, check out the examples. We have lots of them. Have a look at the source code. Hopefully it's fairly well organized. You basically got 4 folders, one for each of the main things I talked about, one folder for transactions, one for constants, one for storage, and one for events. And a folder for the client stuff. And just to say, we're still working actively on this, and it's only going to get better. So the future of Subxt. If you want to know where we're heading with Subxt, check out the milestones on the GitHub repository. And just to kind of highlight some of the main ones that we've been working on, compiling Subxt to WASM is one of the really cool ones that we've ticked off quite recently. So that means if you're writing a Rust-based web app, and you want to use Subxt in that web app that you're compiling to WASM, to WebAssembly, then you can do that now. So that's really awesome. We want to add support for scale-encode and basically making calls a lot more ergonomic and flexible and more robust. So that's something that's coming soon. We want to support decoding the extrinsics in blocks. Right now, you can subscribe to blocks. You can get the bytes representing each transaction, each extrinsic, but you can't decode those bytes. So we want to add the ability to do that. We want to do some kind of light client integration. So we're probably going to add a feature flag and have a light client. So instead of online and offline client, there'll be a light client, and that will use small.dot under the hood to connect to the network via light clients. And then finally, we want to generalize over runtime types. What that really means is, so one of the main things that Subxt is supposed to be good at is if you want to talk to a couple of specific palettes on a node, then the idea is you can write that code in Subxt, and then for any chain that is using those same palettes, you can use the same Subxt code to talk to those palettes and do whatever you want to do with them. That's like half true, but it's not 100% true yet. There's a couple of types that vary between palettes on different nodes, and we want to be able to deal with that somehow. So that's something we're going to be looking at early next year. And like further in the future, we want to generate interfaces for runtime APIs. If you know what runtime APIs are, they're these things that are hidden behind this states call method, and they're quite opaque and quite hard to understand how to use. And I think Subxt could generate an interface for them the same way it does for transactions and make them quite accessible and easy to use. So that means any custom functions that your palette exports, Subxt will understand how to call those functions and make use of them via the RPC interface. So that will be cool too. All right, and that's me done, basically. Just show QR code for the link to the slides. So if you're interested in taking any of those links that are shared, feel free to nab that QR code. And otherwise, I'm done. So if there are any questions, I will take questions.
You can also clap if you like it.
Thank you.
When working with the statically generated types, do you get any IDE support, like autocomplete or stuff like that?
You don't right now because it probably depends on the IDE, but I use VS Code, and in VS Code, it doesn't do the macro expansion from the proc macro, so you don't get the IDE help. We do generate the documentation and things like that in the generated types, so once the IDE support catches up, then we do have all of the information there to hopefully give you a good experience. If you want to debug this thing, then we do provide a CLI tool along with the library. And the CLI tool allows you to do stuff like generate the code and spit out the Rust code instead of using the macro. So like if you have issues with the macro, you want to understand what code is being generated, you can code generate yourself, save it, you can use that code, or you can just inspect it and see what's going on.
OK, thanks.
So on the other hand, so when you're using these dynamical bindings, does that mean that when you connect to the node the first time or something, you download this metadata?
Yeah.
Or do you actually need to recompile every time the node updates?
That's correct, yeah. Every time we connect to a node, it downloads the latest metadata for that node. There's another API that Subxt provides to keep track of runtime updates. So if you connect to a node via Subxt, and then that node does a runtime update at some point while you're connected, Subxt can pick that up and automatically keep the metadata up to date for you for like long-lived connections.
OK, thanks.
Cool. Any other questions? One in the back.
Hello. What's the timeline for decoding extrinsics, and what's the challenge to do that?
The timeline in my head is probably the first quarter next year. The challenge is, so we can dynamically decode them fairly easily. I think that's going to land first. Figuring out how best to statically decode them might be a bit more tricky. So there's like thinking about the signed extensions, for instance, and how to decode that part of an extrinsic is something that maybe just needs a bit of thought. Decoding the core data itself, I think, might be more straightforward.
Thanks.